Hello friends, welcome to chemistry paper 3 lecture. Today in my last lecture we have seen formation of precipitate, then we have seen the digestion and filtration. During the formation of precipitate, some of the impurities get introduced in the precipitate. So we are going to see impurities in analytical precipitate. Now see, these impurities can be introduced in the precipitate by various processes like simultaneous precipitation, or say co-precipitation, or post precipitation. Now simultaneous precipitation means what? If there is an impurity which forms insoluble precipitate along with the precipitation, or insoluble impurity is there which gets precipitated out along with the precipitate required, is called as simultaneous precipitation. For example, during the estimation of barium, if lead is present, lead also gets precipitated out as PbSO4. If we are precipitating barium as barium sulfate, lead sulfate also gets precipitated out. Then next is co-precipitation. Co-precipitation means what? It is also a type of precipitation which is taking place during the process of precipitation. It can take place by two methods: adsorption and occlusion. Now adsorption means what? See, a precipitate get adsorbed on its surface, the salt get adsorbed on the surface, and then secondary layer of impurity is also formed on that surface, and simultaneously means adsorption takes place of impurity also. Now to avoid this, one can stir the solution during digestion, or constant stirring during precipitation will remove the you can say impurity by adsorption. But in case of occlusion, what happens is it gets introduced in the crystal lattice. So it can be done by two ways, that is, if the crystal fits in the lattice, or the crystal get adsorbed on the lattice. If it fits in the lattice, it get inside the lattice, and if it is not fitting, it gets adsorbed, and during the growth of crystal it gets into the lattice. Now next is post precipitation. Post precipitation means what? After a longer period of time of precipitation, the introduction of impurity takes place. For example, when we are precipitating calcium as calcium oxalate, this oxalate ion gets adsorbed on the surface of calcium oxalate, and this can be removed during digestion. So there are various processes by which these impurities can be removed. Now next is washing of the precipitate. it is the precipitate is washed to remove impurity. Now generally we consider the factors as the solubility of precipitate there, then we consider the peptization, the nature of the precipitate. All this is to be considered while washing the precipitate. For example, pure water cannot be used for washing. Why? Because most of the salts are soluble in water, so they may get into the solution, and that is why pure water cannot be used. Secondly, there are chances of precipitate to undergo peptization, and hence pure water cannot be used as washing solution. Generally, the washing solution should contain an ion common with that of the precipitate, so that there are no chances of, you can say, solution going in the precipitate going in the solution. Now see, washing of the solution can be done by taking a large volume of say washing solution once, or it can be used in aliquots, but try to understand small volume of washing solution taken for large number of times removes the impurity and improves the efficiency. For example, say impurity remaining after n number of washings is given by here Cl is the impurity remaining after n number of washing, Co is the impurity present originally, V is the volume of the solution in which the precipitate is in contact, and capital V is the total volume of washing solution, and N is the you can say number of washings. So this was about the washing of the precipitate. Now next is drying or ignition. Heating the precipitate below 250 degree Celsius is called as drying or ignition. It is generally done to remove water molecule from the precipitate. Now see, incineration is also a process. Here the precipitate is heated from 250 degrees Celsius to say 1200. Generally done in muffle furnace. Why this is done? To remove the water, not only to remove water, but also to convert the precipitate into some known precipitate of known composition or compound of known composition. Generally all the hydroxides are converted into oxides. So this was about the unit processes. Now next part is, after doing this, you have to keep your precipitate in desiccator for cooling, and then you can go for weighing. After knowing the weight, you can calculate what amount of substance was present. So the last part of the topic would be applications of gravimetry, that we will see in the next lecture. So thank you.